also used in the making of Star Trek First Contact, where they launched Zefram Cochrane's warp ship from. Nice large antenna, even has a warning label about RF radiation. I should go over there with a light bulb and see if it lights up. So it's going to need decent output power if it works at all. Over the other side there's a good old cellular telephone mast. Now that is likely to be active. Quite a lot of cars here today. It is a Saturday, of course. Tucson seems to have lots of popular attractions, and it all still has snow on the mountains.
Oh, that'll be alright. I'll survive.
Well, you couldn't have picked a better time to do this tour.
Beautiful. Beautiful day.
What you're about to see is unique. Of the original 54 Titan II missile sites, this is the only one left. It's completely intact as it was when it was operational. It is now a museum. The other 53 sites for treaties, they took everything out of the silos, imploded them, filled them with debris, concrete, natural soil. You wouldn't even know they existed. The Titan II was developed to replace the Atlas F, the Titan I. Main reason being this is a retaliatory weapon. The Atlas F, the Titan I, stored them underground, had to bring them to the surface to launch. Could take 15, 30, 45 minutes or better. We realized early on we could have incoming nuclear missiles much sooner than that. We were very vulnerable. So the Titan II was developed to be stored underground, fueled underground, launched underground in a matter of minutes. It was a highly effective weapon. It's a two-stage intercontinental ballistic missile liquid propelled. Two propellants, one a fuel mixture called Aerozine 50 and oxidizer nitrogen tetroxide, both of them extremely toxic, dangerous to work with. Another factor I believe you saw in the movie, hypergolic. No ignition required. Once those two components made contact, you had combustion. Therefore, you never ever wanted those two components to make contact unless you had thrust or it could spill disaster. Another note about the oxidizer. It had a very unstable personality. In fact, at 70 degrees Fahrenheit, it would boil away. So what they did, these are called conditioning hard stands. They'd take the propellants and either bring them up to 60 degrees plus or minus 2. As long as they did that, extremely stable. That missile sat fully loaded in that silo for 20 years. However, that 60 degrees plus or minus 2 had to be maintained 24 hours a day, 7 days a week, 365 a year for 20 continuous years. Rather strange looking metal apparatuses are called territorial protection systems or TPSYs. You had two opposing sets covering the silo closure door. They operate on the Doppler effect. Transmitter, receiver, a constant beam. If that beam is violated for any reason, they'd be alerted immediately in the control center and they would take appropriate action to neutralize any situation. However, the crew would never come topside. This way, please.
Over here, please.
Fully loaded, the missile weighed around 340,000 pounds. Thrust at sea level, first stage engines, 430,000 pounds of thrust. Tremendous margin of safety built within. Interesting note, chamber heated thrust in excess of 5,000 degrees Fahrenheit. This stainless steel bill housing melts at about half that. What did they do? Well, these are hollow side-by-side stainless steel tubes. What they did is they ran the fuel down, reverted it back for combustion, did two things. Kept the shrouding cool enough so it wouldn't melt. Secondly, superheated the fuel for better combustion. Okay, if you'd come around front, please. These are your fuel lines. These are your oxidizer lines. You do not want those in your automobile. 2.5 minutes would burn in excess of 24,900 gallons of fuel and oxidizer. Give you an idea what that means, you've all seen tankers offloading fuel at gas stations. They hold about 8,000 gallons. So in 2.5 minutes it would have consumed more than 3 of those tanker loads, less than 50 seconds a tanker. Took the missile to about 50 miles up and down range. Computer shuts down first stage engines, releases this whole unit, free falls to the earth. You notice that butterfly valve lock? That is a closed locked butterfly valve on the first stage oxidizer line. As long as that remained closed and locked, it was impossible to have an unauthorized or accidental launch of that missile. It could only be opened with a 6-character code from the control center, and that code was not kept on premises. It had to come directly from the President of the United States with the order to launch. You've all seen that gentleman that's always with the President carrying the briefcase that's chained and handcuffed to his wrist. It's called the football. That would have had the code information. Stage 2 took over, burned 6,100 gallons of fuel and oxidizer, took the missile to about 200 miles up and down range. Computer shuts down second stage engine, it separates from the re-entry vehicle, and they continued to an apogee in excess of 500 miles into the atmosphere, depending on the target. Stage 2 engine would not free fall to the earth. What it would do is take a slightly different trajectory, acted as a decoy, so adversary's radar would be confused as to whether they had 1 or 2 incoming nuclear missiles. Okay, this way, please.
But they didn't have to use them.
We have 2 elevated platforms at those that need them. Would you taller people please walk and observe along the side or from the platform and back? This way everyone gets a good look at the missile. Oh yes, many go on. All
Look
this
at
is
pictures all you want, but look at that.
There's also a platform in back. The missile is 10 feet in diameter, 103 feet tall. The silo is 146 feet deep. Now you may have to cover your eyes, but if you look down at the very bottom of the missile, you notice a curved gray ring. That is a thrust mount, held in place by 4 3-story springs. Missile sets on top of that, held in place by 4 explosive nut bolt mechanisms about the size of your wrist, meaning you could have a near nuclear miss. This whole silo would shake, and the missile would be shock isolated and protected. Time of launch, pins would come out, they'd lock the thrust mount into place. 77% of thrust. The explosive nut bolt mechanisms are going to blow away, and in 4 seconds, that missile is out of the tube on its way to target. Son, tell you what, why don't, there's enough room. Why don't you slip right through here where you can see?
Yeah,
You can go underneath here. There you go.
yeah, you can see.
Thank you. Said 77% of thrust, those explosive nut bolt mechanisms are going to blow away, and in 4 seconds that missile is out of the tube on its way to target. However, a missile of this size in this confined area would create so much noise and vibration it would virtually destroy itself before it was free of the launch duct. Therefore, it had to be protected. That was done with 2 sound attenuating systems. If you look around the inside perimeter, you notice curved gray panels, sound absorbent material about 10 inches thick. What you can't see, but directed at the flames beneath the engines, are 4 nozzles that dump 9,000 gallons of water a minute from a 100,000 gallon underground reservoir, creating tremendous amounts of steam, which is also an excellent sound vibration absorber. Back to the movie, you saw the huge plumes coming out the sides. Good portion of that was steam, not exhaust. You notice the conical shaped nose cone atop the missile. That is a re-entry vehicle protected with 2 types of ablative material. What would happen upon re-entry into the atmosphere is it would burn and boil away at a controlled rate, dissipating the heat at a controlled rate long enough to protect the nuclear device within. Largest nuclear device we ever put into an intercontinental ballistic missile. Still classified, estimated to be around 9 megaton, or equivalent to 9 million tons of TNT. To give that a little meaning, that is over 600 times more powerful than the bomb dropped on Hiroshima during World War II. 1 warhead. This way, please.
Supposed to be reused at the
No.
Here comes one in.
Yep. Well, based on a full
Incoming.
hard fact, or what would be left, fix it.
Door. Nice fan.
Silo closure door is massive, weighs 760 tons. High density concrete reinforced with waffled 3.5-inch armor plate. This can withstand anything except a direct nuclear hit. You notice it's in a half open position, half of it still covering the missile. Huge concrete blocks preventing it from moving any further. It's for a reason. It's to let any country in the world with their satellites photograph this operation and realize it's not an operable missile site. And believe me, they do it all the time. In its time, one of the most sophisticated operations in the world, but unless you get the order through from the president, and only the president of the United States for launch, this whole thing wasn't worth very much. So to guarantee that, besides a hardwire, they had 4 radio antenna backup systems. Looks like a TP, high frequency, single sideband to communicate anywhere in the world. To back it up very deep in a hardened site, Collins telescoping. Go from 7.5 to 117 feet in height, depending on frequency. To back that up, looks like an Aeroderrick with a white pencil on top of it, high frequency diversity antenna, probably the most important antenna. Therefore, if that derrick leaned any more than 7 degrees in any direction, they'd be alerted immediately in the control center. They could activate 2 backup pop-up antennas. One we have in a raised position, the other one between the 2 posts still in its silo. To back that up, that gray cone in front of the cyclone fence, ultra high frequency. Communicate with any Air Force command in the air at that time. And then, to back all of that up, buried deep underground, is a very low frequency survival antenna. Just like the nuclear subs use the ocean to transmit, this uses the Earth itself. So to guarantee that message could get through besides a hard wire, they had 4 redundant radio antenna backup systems for a message that fortunately never had to come through. This way, please. Accompany the rest of the trip with my associate, Cliff. You notice one last set of tipsies? That square box was not between them when this was operational. What they protected was a big steel grate over a 35-foot air shaft. Supplied all the air for the complex. Also used as a secondary escape route. Again, in the event of a near nuclear miss, there's a very good chance the only entrance, the access portal, would have been totally destroyed. What the crew could do from downside in that event or any other emergency is open up a blast valve, climb up 41 metal rungs, release the grate, use it as a secondary escape route. What you see sitting in there now is a typical Arizona swamp cooler. We can't afford that 75 ton of air conditioning the Air Force could to maintain that 60 degrees plus or minus 2. Even at that time ran hundreds of dollars a day to operate. But let me tell you, when it's 108 degrees, faux sun, no breeze, dead of summer, you'd be amazed how that economical unit keeps you refreshed downside. Entry procedure. You had an incoming crew of 4. 2 officers, 2 enlisted men. They came in for a 24-hour tour of duty. They had arrived at the gate. The commander made his first of 4 phone calls to gain entry to the control center. Everything in order, gate open electrically, drove in, slammed shut and locked. At the base's first flight of steps, commander made a second phone call. 3 minutes to do so. And that was by design, because in the event he anticipated any type of problem, such as breach of security, hesitate. Unless they got that second phone call within 3 minutes, they'd go into 100% lockdown, air security called into place. If everything was in order, door would be open electrically, he'd step inside, it would slam shut and lock. He is now sealed in what's known as the entrapment area or choke point. Another flight of steps completely enclosed in wire mesh. Door at the top, gate at the bottom, only one could be opened electrically at a time. He then makes his third phone call while being observed by an in-house television camera. Everything in order, gives a code of the day printed on a piece of paper. When finished, next to him is a red coffee can, or if you've been to service, GI butt can. They observe via the camera as he lights that coated paper. They watch the ashes drop into the can. That code was never, ever supposed to that second gate. That's where we're going now. There's a light differential when you go down the steps. If you have sunglasses on, you may want to take them off till your eyes adjust. I understand there's 4 people for the elevator. If you'd step aside with my associate Cliff. Rest of you follow me, please. Don't worry about the watch for rattlesnake signs. We've got most of them. That's a terrible summer joke. Rarely do we see them anymore. If we do, they're picked up, they're released unharmed in the desert. This is their home too. They were here first, and we respect that. Please hold on to the rails you go down. And I need someone, the first one down, you look strong enough, is hold the door open till everybody gets through and then slam it shut so we can maintain our air circulation. Okay, thanks. Let's go on down.
Lift going down.
I don't think they care about it. Like, why not destroy it? Well, if they're destroyed, it's not a problem. It's just getting the message.
Yeah.
stairs. Ah, yes, it's a nice staircase. It's a bit modern.
And ladies, as you can see, this will go for big groups as best we can. The area now is built to very high industrial standards, but again to the Air Force, known as the soft area. Again, in the event of a near nuclear miss, there is a very good chance this whole thing was in total collapse, destroyed. But behind these closed and locked glass doors, and always kept closed and locked, was a hardened area. Closed and locked, and they always were, could withstand in excess of 1,000 pounds per square inch overpressure. Does it? So you realize a tornado only requires 5 to 8 pounds overpressure to completely destroy your house. Very well built. Commander makes his fourth and final phone call. Request permission to enter blast doors 6, 7, and 8. Everything in order, they depress a button, he depresses a button, hydraulic pins retracted, then and only then could the sealed blast door be opened. Come on in.
In the chamber. Yes, a nice little.
Now I can see you have now entered the safest area that you're going to be in your life, probably. Because when operational, and these doors are always kept closed and locked, anything beyond this point could withstand anything except a direct nuclear hit. Boy, I've used that term a lot, haven't I? So I'm going to give you a very brief, and believe me, brief and loose description of what that means. Given an estimated 9 megaton warhead, given these soil conditions, given the fact that it's a ground burst, not an air burst, and by the way, a ground burst, 0 to 7,000 feet up. Given all those conditions, would have left a crater over 200 feet deep, a mile in diameter. So this, being a 146-foot complex, any nuclear impact within a mile diameter of this location would have taken it out completely. Commander comes in with the rest of his crew and supplies everything in order, closes that blast door, depresses a button, hydraulic pins go back into place, locking, sealing that blast door. Then and only then did it trip micro switches, sending power to this door so it could be opened. When operational, you could never ever have more than one door open at a time. Okay, I need the 2 strongest guys down here, I found them. Just step back away from the door, please, you two. You guys each put a hand on that handle. Put that on the door, put a hand on the handle, each one of you. Okay, let's pull back, guys. Oh, look at that. Now you have to push it back. Push it back, guys. 6,000, oh, just use your hands. It's easier on the knuckles. There you go. 6,000 pounds a door they just moved, and look how beautifully that went. Yet that's held in place by only 2 hinges. There's no wheels, pulleys, counterweights, and no one behind there pushing. Yet the distance from the floor to the bottom of that door, about a 1/4 inch, same as it was first back 45 years ago. Give you an idea of the quality that went into this unit. Then you look over here and go, wow, what happened to electricians the night before? Nothing. By design, everything here on out has to have the ability to absorb tremendous seismic shock. Critical motor control panels suspended on spring-loaded canisters. In the event of massive shock, they move up and down, absorbing it. And what looks like sloppiness? Slack, so they can do so and not lose the integrity of the cables. Everything. Launch critical, here on out, shock isolated on springs. Look up. standard lighting, fluorescent lighting, emergency lighting, everything on springs. Come on in.
Good old Cutler Hammer. Boo.
Come all in, please. What's this? Have a girl sitting in commander's chair?
I know.
I do that for a reason. To illustrate the fact that yes, after the first decade, we did have female crew members. In fact, one of the last commanders of this unit, before it was deactivated, Captain Yvonne Morse, is now a museum director. You notice I mentioned them, you pass blast doors here on out, shock isolated on springs. These units are hard mounted to the floor. Why? You're actually in a very unique structure. You're in the middle of a 3-story unit, built like a bird cage. Round dome top, flat bottom. This whole 3-story unit suspended on 8 mammoth springs. This whole 3-story unit can virtually move up and down up to 18 inches, side to side up to 12. So everything in it is shock isolated, no need for individual springs. We have a couple more chairs if you want to sell them.
Yes.
First floor right above us, crew's quarters, sparse but adequate. You had 4 bunk beds, a latrine, small kitchen, that was it. Second story, heart of the operation control center. Third level beneath us was an equipment bay. Heating, cooling, power, among other things, 2 28-volt battery power units. Big. Size of this console, fully charged, kept on a trickle charge 24 hours a day. Talk about those a little bit later. This was a no-blown zone, meaning 24 hours a day. You had to have a minimum of 2 people, eye-to-eye contact. In this area, one had to be a commissioned officer. If you had 2 of the crew down here working, and the other 2 were upstairs resting or eating, and someone had to step behind this console for a second, you brought down additional people. That side, this side, eye-to-eye contact. For safety and security reasons, no one was ever allowed to do anything without being observed by another person. Yes, there's one only one exception to that rule in this whole complex. For obvious reasons, you could be alone in crew's quarters, but nothing launch critical was up there. Commander, usually captain or major, sat at the launch console. Deputy commander, usually first or second lieutenant, sat at this console. Here we have the EWAL safe, emergency water safe, very important. Had most, but not all, the information required for launch. You notice 2 combination locks? 2 officers owned their own locks, top secret combinations, carried their locks with them. Outgoing officers took their locks off. Incoming officers examined contents, everything in order. Incoming officers put on their padlocks. 2 officers, total agreement, ever open that safe. Never one person. All the antenna we discussed topside, this is a terminus for all of them. They were controlled, regulated by the deputy commander. He is also in charge of the launch clock. It's an 8-day wind-up, wound every 7th day. It's a 24-hour clock set on Greenwich Mean Time or in the military Zulu time. Meaning, if it's 1,200 hours here, 1,200 hours anywhere in the world, you do not worry about time zones. Was it accurate?
Hope so.
Yeah, yes it was. because it was set or hacked twice a day. When an atomic clock, Boulder, Colorado, it was accurate within 1 second. Now, besides the 2 commissioned officers, you had 2 very highly trained enlisted men. One was the MFT, Missile Facilities Technician. He had to have an absolute thorough knowledge of a multitude of systems in this complex. Heating, cooling, power, hydraulics, pneumatics, just to mention a few. One of the critical ones he maintained was power. We bought 480 AC volts from commercial source like any other business. However, monsoons, accidents, outages, couldn't afford that. So if we lost power here, and the third level in the silo was a 350 kW diesel generator. The oil kept warm 24 hours a day, kicked on immediately, 60 seconds up to full power. Not good enough. Because you had spinning gyros, other sensitive electronics on that missile that couldn't be without energy for a second. So what would happen? If you lost power here, those 2 28-volt battery power units came on stream, carried the load till the generator was up to full power. In fact, enough energy contained in those 2 battery power units to actually launch the missile completely independent of any other power source to this complex. Pretty good engineering.
Yes.
The other highly trained enlisted man was a BMAT, Ballistics Missile Analyst Technician. Probably computer guru of the day. His responsibilities, state of readiness, the onboard computer, all electronics to launch this missile 24 hours a day. Top side pointed out those tipsies to you. If they are violated, the lights would indicate which set off an alarm advising the crew. Here we have control monitor group. Critical. Remember that first stage oxidizer line? Closed lock butterfly valve, impossible to launch this missile. This was operable. Had a steel pin mechanism in it. Could only be retracted to make that operable for a launch if you put in the correct 6-digit combination. 6 wheels, 16 characters a wheel. Anyone have a guess as to how many possible combinations? I know you're thinking 16,777,216.
How did you know?
What a guess! One of those would work. One of them. Still not good enough for the Air Force. They do not like chance factors. So in and above that whole system, they also put in a tries column. Tries, T-R-Y, tries. For the lifetime of that unit, we're not talking a month or 2 months. We're not talking a year or 5 years. For the lifetime of that unit, you could put in 6 incorrect combinations. At 7th attempt, even if it was the right combination, would cause that unit to commit electronic suicide. They would immediately have to bring out a specialized crew to reset and calibrate. So as you can well imagine, if the crew was at all concerned about their careers in the Air Force, they always treated that with a lot of respect. Targeting information. Target 1, 2, 3. Turn a key, set it for air or ground burst. Notice on the console, target 1, 2, 3 set on target 2. The crew never knew target destinations. In fact, still classified, still only known as target 1, 2, 3. You did not need to put the crew in a position where any moral or political judgments had to be drawn. They were trained to do a job, and if ordered, to do it. Here we have MGAC, Missile Guidance Alignment and Checkout Crew. This was the interface between the control center onboard computer. 1960s technologies filled every one of these panels to the brim. Latest technology. System designed will last 10 years, spare parts for 10 years. But after a decade, the Air Force said, wait a minute, this is a very good system. We want to keep it longer. Major problems. Obsolete technology, lack of replacement parts. However, MIT, working in conjunction with Duck Electronics, had come up with a universal space guidance system, which was modified and everything condensed into one panel, replacing all the other panels and extending a 10-year to more than 24-year lifespan. Punch tape. The two officers would feed the onboard computer the 3 targets via punch tape. Computer would acknowledge with another tape, more or less saying good input. Punch tape. It's archaic. Technology dates back to weaving looms, Great Britain, early 1800s. What's it doing here? One very, very good reason. It is almost foolproof. You cannot electrically, magnetically add, delete, alter information without being aware of it, such as can happen on any CD or magnetic tape. If you had to, you could physically take that tape out and examine it. May not know what's on it, sure check to see if it's been tampered with. Extremely foolproof. Now we're going to get serious for a moment. We're going to go through a simulated launch. We're going to use the same procedure the crew would have used if indeed they had incoming nuclear missiles. First thing the crew would hear over a set of PAS speakers, primary alert system commander had a set, deputy had a set. They'd hear a loud warbling sound to get the attention of the crew, advising them to listen up and copy. The 2 commanders would immediately grab their top secret code reference books, sit in front of the respective speakers, recording alphanumeric message character for character. And if they matched exactly, and I mean exactly 100%, it was then a valid message, and they would proceed to open the E-wall safe. Valid message, ready to go, right? Not quite. You turn that key to the right and hold it there. 3, 2, 1, launch. 4, 3, 2, 1. Thank you, and let go. You have started sequence, cannot be stopped. Launch enable light comes on. Correct code put in. Green light, we are ready to fire. Battery activated light, this time 2 dry batteries on board the missile. Force fed electrolyte, 28 seconds going to be up full power. HAPS light comes on. At this time, the missile has assumed its own energy source, no longer relies on this complex for its power. Silo soft light comes on. 706-ton Silo closure doors opening. What's it going to do? Violate those 15. Guidance go fire engines. 9,000 gallons of water a minute pouring onto those flames. Tremendous amounts of fire steam in a hole, setting off a whole bank of klaxon fire alarms. Very good. Guidance go light represents the fact that the onboard computer has now assumed its own identity. It knows where it is, where it's going, how it's going to get there, and what it is going to do at target. Last we have liftoff. 77% of thrust. Those explosive nut bolt mechanisms are going to blow away, and in 4 seconds, that missile is out of the tube on its way to target. It cannot be stopped. It cannot be destroyed. It cannot be altered. Because we had to assume if we had that technology, so did our adversaries. We did not want that missile coming back at us. 30 to 35 minutes from now, target 2 is going to cease to exist. It's going to be vaporized in a fireball exceeding 3 miles in diameter, core heat in excess of 27 million degrees Fahrenheit. This was not Disneyland. The crew Having completed their mission, they close the silo closure door, they put out the fires, they power down, and they wait for the incoming nuclear missiles to impact. Hopefully the crew survives. If they do, they are to remain below for further communications. They have approximately 30 days of food and water, less of recirculated air. The air is going to go first. At the end of that time, if they've heard nothing, 2 options. Remain below and slowly suffocate, or go topside, see what or if anything was left, the world they once